Thank you, thank you. I want to start asking a big favor. I mean, who is having fun? No, come on. Who is having fun? I want to ask a big favor of you. This has been a fantastic conference since the moment I arrived. These people work a lot, and I've been a lot of conference, and this is in the top of the top, man. I don't know if you go to conference all the time, but I do. So I want to say thank you to the organizers, thank you to the technical team who were working very late, and they have my notes here. Thank you, guys. You're awesome. So I want to say, please, with me, a big token of, wait, we're going to do a wave, okay? You call it a Mexican wave for some reason. I'm come from South America. I just call it a wave. If you have never done a wave before, that's fine. Don't panic. You just do whatever the person to your right or to your left is doing, and you will be fine. Careful if you have something on your legs, okay? No coffee spills or no laptop to be broken, and then you're going to put the blame on me, okay? So we're going to go from left to right, and then we're going to return the wave from right to left, okay? So at the count, 1, 2, 3, wave. And we return. Fantastic. And big round of applause to all the team. Thank you, Ivo. Thank you, Christian. Thank you, guys. You're amazing. You're amazing. I need to start with a big disclaimer because I have been invited in my individual capacity. That means that everything that you're going to hear from me today is my opinion, and it doesn't represent the opinion of my employer. Okay? Said that, let's start with the talk. 10 years ago, I had to make a big decision. Like Ivo said, today you're going to hear me talking a lot about making decisions. I had to move from Venezuela to Europe. But what city? So after doing a lot of spreadsheets, having a lot of conversations with friends, consulting the tarot, and a lot of things, I made a decision to go for, ta-da, Barcelona. Anyone here been in Barcelona? I see you live in Barcelona. I have met a lot of people who live in Barcelona, which is fantastic and at the same time scary because I'm going to say a lot of things of Barcelona that you need to check with me if it's true or not. I cannot regret that decision. It was a fantastic time, and I really enjoyed it. It's a multicultural city. If you haven't been there, please put it on your list. I was fascinated because I fell in love of the architecture of the city. And a lot of the architecture monumental things that you will find there were built by a guy who is quoted behind me, Antoni Gaudi. Do you recognize that building? Yeah? The name? Sagrada Familia. If you go to Barcelona and you see it from the outside and you just like take the picture and say like, I just met the Sagrada Familia and just keep it, you're doing something very wrong. Because Sagrada Familia, without the religion aspect, is a fascinating building to go inside. And it's even more fascinating when you take the audio guide. Please do. Because you will have a perspective of how this magnificent building was designed and being built. It's still not finished. It's under construction. Someday they will finish. There is a quote, as you were walking through the Sagrada Familia, this is a museum, and you will find multiple quotes from Antoni Gaudi. So we're going to start with one of the quotes. And Gaudi says, "Originality consists in returning to the origins." My talk today is about architecture, human-built structures. So let's go to the origins. The first building or the first structure so far found human-made is Göbekli Tepe. And I apologize for the people who speak Turkish here. It's in Turkey. And they dated 9,600 before the Common Era. I was expecting like, oof, it's a long time ago. So you have a perspective of how old it is. The pyramids of Giza are 2,580 before the Common Era. Almost 7,000 years difference. The Colosseum of Italy, only 70 years before the Common Era. Sagrada Familia started on 1882, still under construction, so that's why I don't put that over the date. The Turing machine was built in 1936, and we have Stephen Robertson, who is an alumni of that amazing school from Alan Turing. I consider Alan Turing, the Turing machine, the first production code, because it's the first code that we actually put in production to get some value out of it. But my point here is that between the Turing machine and Göbekli Tepe, there are almost 12,000 years. The Turing machine was less than 100 years ago. So we do have a lot of experience building physical structure. That means that we have a lot to learn from that branch. It's not a surprise that many authors do that analogy as well. Robert Martin, in the fantastic book, Clean Architecture, put it very simple. He says, like, physical structures, whether magnificent or mundane, they have to respect the physics of gravity and their materials. Software has very little care for gravity. And I think that's what made me jump into become a software engineer. Because I connect with my inner child when I was playing with the Legos. I had a massive bag of Legos with me. I don't know if they were original Legos, but they were Legos nonetheless. And there was no limit to the imagination that was the things that I can build with it. And I feel exactly the same time when I'm building software. The only limitation so far is budget, but computing is getting cheaper and cheaper and cheaper. And with my Legos was the budget, which now is controlled by my wife, which I'm trying to negotiate. So that's where I went. I've been working as a software engineer for more than 10 years ago. I'm currently working as a lead software engineer for JP Morgan, and I love it. It's fascinating. So, Jose, why evolutionary architecture? Look, I have worked on different domains, multiple different technology stacks. I was sharing some anecdotes with other people here. I started with the PHP in the university, and then I moved to Java. One thing has been very constant in my career. Dealing with the business, they always want frequent change and fast. They're always changing something on the application, and they don't want to wait for it. They want it now. So I love when I found a book called Building Evolutionary Architecture, when they define evolutionary architecture to the answer of two questions. How is long-term planning possible when everything changes all the time? And how can I prevent it from degrading over time? Pretty much it's very simple. How can I guarantee that always providing value to my business? And how can I provide that that value never degrades over time, that I can continue with that rate of speed? They call it velocity in the Agile framework. And the thing that I have found very common to answer that question, those two questions, is decision-making. Decision-making is critical to actually guarantee the answer of those two questions to continue very fast. Now, decisions are abundant. They are very stressful. Since we wake up in the morning, what pair of socks should I choose? What kind of shirt? Should I go for shorts or pants? That was me only in the morning. When you open your email, and it doesn't matter what level of the organization you are, if you are in the developer, medium management, or senior management, you have to make decisions every single day. And we are one decision away from shaping the evolution of your system or stopping the evolution of your system. One decision away. And this is what we're going to talk about today. And I'm going to be using Gaudi's framework of decision on not only the Sagrada Familia, but a lot of buildings that he had. to make sure that that evolution continues to be there and is very fast. The first point comes from a fantastic book. I have made so many notes on that book that is unrecognizable. I cannot even borrow it because it will be completely scratched by me. It's from Gregor Hope, the Software Architecture Elevator. And he starts narrowing down a chapter on what decisions should we focus. And he said, well, the decision has to be non-trivial decision. If you are thinking, what log library should I use for my Python application, a script that I'm running on day-to-day to write my tweets or something like that, that's a trivial decision. You should focus on the non-trivial ones. It must have a downside. It must have a consequence. Someone must scream or debate about that decision. And it must be meaningful. You have to justify your decision. When you are making a decision, you will have multiple alternatives. Okay, you have a problem, you will have alternative 1, 2, 3. But there is something that you have to aim. And in my experience, is simplicity. Now, I see your faces and you say like, of course, Jose, simplicity. Why wouldn't you choose simplicity? Trust me, some people don't go for simplicity. We saw the Dino 4 hours just changing a tag experience. And in my experience, complexity comes from 2 sources. The first one, very uncommon, ego. People feel proud of creating, they call it clever, they don't call it complex, right? It's clever solutions. Guilty as charged. On the university, I was just bragging to my friends, look how I made this multi-thread. It calls this join, and then that calls back here, and then makes function. It sends a fax to this number, and then the person will write back. I was super proud of that. That works okay when you're working only in one application that you only maintain, but the moment that you involve other people into the application, good luck. And that's where PRs are super helpful, in my opinion. A PR, people say, oh, of course, let me send the PR so I can do a quality check of your code. Sometimes I don't have the context of the PR. Sometimes I get PR from other teams, from other people, and I really don't know their domain. So what I look at the PR is, can I really understand it? Is it simple enough for me to read it? So the first red flag, when you're sending a PR, or someone is sending you a PR, is when the PR link comes, and then they send you a message that looks like, do you have 5 minutes to walk you through my solution? That's a red flag. Because your code should be able to defend themselves. Simple enough. And the second cause of complexity is the unwanted complexity. Now, what do I mean by unwanted complexity? How can I end up with a complex solution where I'm aiming for simplicity? Is when I don't have it very clear. I'll give you an example. A critical decision could be, oh, we need to use a caching solution. All right. So I read, I don't know, some articles, or I saw a video, or I went to a conference when they were suggesting the banana caching system. Wow, banana caching system, fantastic, let's go for that. Have you tried? No. But the guy from the conference was very confident that we can actually implement the banana system. Right. So you don't have it very clear. It's fuzzy. So what happens is you start implementing banana system, and then, oh my God, it doesn't work with this, so it's complemented with that. And I saw on whatever AI, the generative AI tool that you're using as a copilot, that it suggests you this, and then you copy and paste something from Stack Overflow. Oh my God, I end up in another rabbit hole and try to make it work. Fantastic. Congratulations, it's a complex solution. You aim for simplicity, but you didn't have it very clear. You end up with complexity. And the thing with complexity is that ends up with something that we really don't understand, and your teammates won't understand. And humans, we fear of the things that we don't understand. And on Yoda's words, fear leads to anger. Anger leads to hate. Hate leads to suffering. And when we are suffering, we saw it from Dino's presentation, what do? You call for a rewrite. That's it. Trying to justify to your business that you have to rewrite something that you built only 2 years ago, and they already pay millions of dollars of that. It's not an easy one. You have to struggle. So what happens when you have the complexity, the other consequence is that you lose control. And when you lose control, you become unpredictable. And we started talking about evolutionary architecture. You want your solutions fast and cheap. How can you provide solutions fast and cheap if you are not in control of your system, if you cannot predict how fast it will take you to make a change? So, uncertainty becomes complexity best friend. How can we deal with complexity or with uncertainty? We experiment. And here's the first lesson from Gaudi on decision making. We have to invest some time on what? That's a model, not of the Sagrada Familia. It is in the Sagrada Familia Museum, but that's not the Sagrada Familia. That's another church that Gaudi was building. But you can see that the model, that's a model, is upside down. He's using gravity to model it and take a look at the shapes, which is fascinating. I don't know anything about civil engineering architecture, but I look at that and say, like, fantastic, wow. Now, I don't believe that Gaudi did that at, I don't know, 5 p.m. He said, like, let's do that, and we finish by dinner. No. That definitely took a lot of time. And we saw from another conference today that prototyping should take time, take effort, right? Less effort than building the Sagrada Familia, for sure. But you are failing. You are aiming for failure. You are testing something. But most important about failing is failing fast. You don't want to end up with something that you don't know is going to work. So that's the first tool that we can use. And the second one from Gaudi is on the Nativity Gate. You will find these very realistic figures, stone figures. They represent different stages of the life of Jesus Christ. And the way that the team of Gaudi is actually doing this is by taking real people from the town, making cast out of them, and once they have a cast, they can start using them as a reference to shape the stone. Very similar to what we call a proof of concept. A proof of concept is something that will never in your life see the light of production. You are just using it as a disposable code just to test something. It could be a new technology, or a framework, or a provider, whatever. But the rule number one of proof of concept is you never use your domain on it. If you are building a payment system, I will never create a payment system as a POC. Why? Because if for some reason your business sees that, it will say, it's ready, it's done, ship it. You don't. The equivalent will be to Gaudi to hang up the people in the facade or something. It will be disastrous. It will not survive the time, and it will definitely shut down your velocity, and it will definitely slow down your evolution of your system. And the third example from Gaudi is that he's delegating decisions. He's not going to paint the Sagrada Familia. He's going to make the sun painted through glazed windows. In fact, if you visit the Sagrada Familia at different time of the days, you will see a completely different building. Even from different seasons, from autumn to spring, you will see different shades of colors in the walls, which I found fascinating. This goes very well, what Gregor Hope also says, apply unnecessary creativity. Sometimes we don't have to create everything ourselves. Sometimes we can just delegate with a third-party provider or use an open source library, and we can focus on the things that we should be good at it, which is the core business solution. Now, simple things should be simple, complex things should be possible. Gregor Hope continues saying on that book. I'm not saying that the Sagrada Familia is simple. Sagrada Familia is a complex project, but they use documentation. Okay? The problem is that in 1936, a group of people burned the crypt of Gaudi, which was his workshop at the time, and they burned a lot of the documentation of the Sagrada Familia. Gaudi has been dead for 10 years. He died tragically in 1926. gets hit by a tramway. So they don't have the visionary person to actually continue. It takes the team, how many years you think, to continue? 6. 6 years. These people were working with Gaudi. They were side by side looking at his decision, working with him, but they lost the documentation, they lost the vision. So you stop at 6 years. This is where I get so scared when people say, oh, we will do the documentation later. Later. You do the documentation as you go, because that's your vision. So it's very important that we do. Now, how can we document things? I love diagrams. I really, really enjoy diagrams. But, in the words of Gregor Hope again, we should aim to make diagrams that help you answer good decisions. If your diagram doesn't do that, it's a piece of art. And we, architects, are terrible, terrible artists. Something that the civil engineer does very well is standardizing notation. I was talking to Steven on a coffee that a bathroom designed by an architect in South America will be easily identifiable by a Chinese architect. Immediately, he will say, oh, here is the toilet. Perfect. If you try that with a microservices, good luck. I fell in love with C4 model. Anyone work with C4? No? Oh. UML? See? We don't have standards. C4 is a fantastic notation agnostic way of modeling, and you can visit that page and see the video from Simon Brown. He will definitely explain it better than me, but quickly, is a way to dive in from the most abstract point of view, from the most high level of the application, and then you can zoom in on the parts that you care. And the beautiful of this model is that you can show it to your business, non-technical partners, and you can go down to your developers. That's why the analogy of the elevator in his book, and show the diagram, and they will understand it. Here, we are looking at internet banking system. This is called context. C4, 4 C's. The first C, context. Internet banking system, we have our personas, we have an email system, who is a third-party system, and we have the mainframe banking system, who is not our system. This is our system. If we want to zoom in, it will be like zooming on a map. Oh, now, sorry, I need to go back. Now the internet banking system, I can see the containers that compose that internet banking system, and it's beautiful. I can see that it has a web application, single application, a mobile app. Oh, API application. Oh, that's the one I want to see. Fantastic. You can just click in there, and just like on a map, you are zooming in. And now I am in the component layer. The component layer, if you're a Java developer, is like the folders that compose your project. That's pretty much an analogy. If I want to zoom in into the mainframe banking, then I see the code, which is the final C. You will never generate that diagram and write the code. No, you first write the code, and then you tell your IDE to export that. And this is very similar to UML. But that's it. It's beautiful. It works. And for me, it has been a fantastic way to document my decisions as I go through. Now, what do I do with that diagram? Where do I put that diagram? Well, we have to talk about ADRs or SATs, architecture decision records or software architecture decisions. I prefer ADR because SAT. An ADR is a very simple document, and you can actually personalize this as much as you want and how much value it provides for you and for your team. It's pretty much a document like this. You can find that in the Fundamentals of Software Architecture. That book is fantastic. And let's start from the beginning, the title. What is the statement, the decision that you're making? What is the status? Is it proposed? It has been accepted, or it has been superseded by another decision? in the context, this is my favorite part, because we said that when we're making a decision, we have alternative. And it's in the context that we're going to provide the alternative. Alternative 1, 2, 3. For each alternative, I like to put the pros and cons. And also the constraints. Sometimes we jump into judgment very fast. We look at the solution and we say like, ha! Oh my God, poor team, they were doing this and that. You have no idea what the constraints of the budget was, or how much time they had to make that decision. So it's important that you put it in the context, so for future people that come along into the project, they understand what were you taking into consideration, and then the decision that you're making. Justify your decision, technically and business-wise. If you cannot justify your decision technically, and financially, that decision doesn't match the criteria that we spoke at the beginning, okay? And then the consequence, the compliance in the notes. I want to make emphasis on the compliance. A lot of people skip the compliance, but I love the compliance part because here I will put the KPI, the OKR, the number, the thing that you need to track to make this decision compliant. If that number goes below a specific range or a specific threshold, you know that you made a wrong decision and you need to make a turn. So you go here and you evaluate all the decisions around that and you say like, no, this decision actually degraded the system. And it could be the velocity of the development that you were doing. It could be the time that it took a junior developer, we saw that from Dino, to make a feature. It can be whatever you want. But if that thing got impacted, then you know you have an issue. And if you have the discipline to do this over time, you build yourself a time machine. You can go back to the beginning of that beautiful system and evaluate every single decision that they made. And it's beautiful. It really, really works. Of course, we have to talk about the anti-patterns. So you can be stuck a lot of time before you actually make a decision just because you're planning and you jump into what they call analysis paralysis. You can be 6 months just in a room talking to people and say like, no, let's go for that. No, let's better do that. No, I'm going to call a friend and make sure. Just start with something, mate. Okay? There is no good or bad decision. It's just a decision that you have to make. We're not talking about how to deal with that in a further slide. The Groundhog Day, sorry. Have you seen the movie, Bill Murray? Yeah? So he repeats that 2nd of February over and over and over again. And I had that experience so many times. So tell me again why we're sending the data to System B. Oh, we spoke about this, right? Yeah. I think it was like last year. We know that System B needs the data, but I don't remember why. But it does need it. You're sure? I don't think so. I think we can just cut that part of the code and then we'll be fine. No. I'm sure that you revisit and revisit that over and over again, and then you end up with this one, my favorite. I'm sure that I sent you that on an email. When? I think it was before the pandemic. Good luck finding that email. So don't do that. Use a system where you can store those decisions and you can archive them and you can see the evolution of that. Like source system, control system will do fantastically for archiving your decisions, even with your code. Just ship a single page. There are some people who are using command line interface to, after doing a commit message, put quickly in 3 lines. It doesn't take more than 3 lines. Why are you making that decision? And that's it. That's pretty much enough. But if you have been doing this from the beginning of the project, you will end up, with a lot of documentation. So now, what do? I had to put AI on the slides. It's a very common use case. We saw it from this morning from some of the speakers that one of the most use cases is that I have a lot of blind data that I don't want to make it public, but I want to ingest it into a model so the model can actually provide that data to me. And you can start asking simple questions about the evolution of your system. I don't have to be talking to the architect for hours. I don't have to trouble my senior engineers to spend time with the junior developers to answer questions about it. They can just ask the model and say like, can you please tell me why we went for PHP? Sure, I will tell you that in 1991, someone decided to ba. And that's beautiful, right? Also, you're missing one key aspect when you're talking about decisions, it's the coupling. Coupling. It's almost unavoidable. There are multiple layers of coupling. I think domain coupling is the most difficult to get away from it. And I was talking about that you should not be stuck on analysis paralysis. You should go for a decision. Now, the important thing when you're making that decision, one other important thing when you're making that decision is that you can revert it easily. And it's Martin Fowler, who I think is a podcast that I was listening that got that quote. Think about how they can avoid irreversibility in their decisions. I call it the easy reversibility principle. You went for a decision, the decision is very, very wrong, and I just click here, or it's very easy for me to revert back to another alternative. I don't create too much coupling in my system to that decision. And I know coupling is a very abstract concept, so I'm going to jump into another analogy. Jose, you're killing me with analogies, I know, but I live with a person who is my wife, and she has 87 plants in the house. So I do know a little bit of plants. It's not a joke, it's actually true. And the thing with plants is that they actually grow, and they grow the roots. So at some point, you have to move the plant from one pot to another pot. Okay, is that transpotting? That's a movie from Scotland. Sorry? Repotting, thank you, repotting. And one very interesting fact is that these pots are made of clay. And one of the reasons they made it of clay is because you can break them very easily. So the plant doesn't suffer when it's moving from one pot to another. We architects, engineers, software people who care here are always in a migration. We're always moving from one pot to another. If you are in BSI, you need to move to the cloud. If you're in the cloud, you need to move to serverless. And I have no idea what is in the future. So you always want to be in a position of portability. So pay attention to your roots. Create interfaces, abstraction layers that don't make that banana caching system too embedded into your application, please. I love this slide because it's where I'm connecting the software engineer world and the physical structure world, physical engineer worlds. I don't know who was first, the chicken or the egg, but I love that now they make houses that are modular builds. So, oh man, we missed one bathroom, no problem. I just put it in top of the other one and just put it there. We could use containers to actually do modular solutions. How is Gaudi dealing with irreversibility? One of the boldest decisions from Gaudi, and this is according to the audio guy, the people from Barcelona can correct me when we're in the party, is that he knew from the beginning that he was not going to finish the Sagrada Familia. This is the part where you do, wow. I don't think I can jump in a project. I don't know, it depends. Send me something in LinkedIn. When you tell me, no, Jose, you're not going to finish the entire project because in your lifetime, there is not enough time to do it. I don't know, it's like I said, I love building things, but the most satisfying part of building things is seeing the realization of it. Gaudi didn't went for that. He could have gone for a much simpler design that he definitely could have finished, but he didn't. But one thing that Gaudi was aiming to finish, and he almost did, was the Nativity Gate. He actually just missed that tower bell here by a factor of years or months, not too far. So what Gaudi is doing here is what I think, and we can discuss this in the party, the opposite of irreversibility principle. He's avoiding that. Because how can you mess up something that looks like this? He knows that the people who are going to continue his work will use this as a framework. And this is what I think us architects, engineers can use this example to build larger systems. I, as a principal engineer, as a lead engineer, I cannot be involved on every single component that I build. But I can definitely bootstrap and leave something for the other developers to carry on. How many of you have contributed in a class, or just say a class, a file where it has code, that it looks so clean, so neat, that when you are trying to make a change in that, you say like, ooh, it's difficult, isn't it? Because it looks so clean, so beautiful, so well documented, so simple. You pay attention to, oh, I want to make the change that it goes in context with this way of building. But we also have worked in 1,500 line class, right? Where it doesn't matter. I mean, come on, at this time, it's another strap for the tiger. I think that's an analogy that we can use from Gaudi in his way of building. I started with one quote from Gaudi, and I want to finish with another quote from Gaudi. To do things right, first you need to love. You need love, and then you need the technique. I can spend hours here talking, and you can read books, and it doesn't matter how much money your company pays you from 9 to 5. To build evolutionary architecture, to make the right decisions, you have to be altruistic. You can't just think about yourself and your goals, or your short-term goals. You have to think about the company, the system, your users, and the developers, your current developers, and your future developers. When they look at the code, once you have moved on to another company and they see your name, what you want to have is, oh my God, thank you, mate. Thank you for taking the care of doing the documentation correctly, to spending the time to make the solution so simple, because now my life is way more simple. So takeaways. Decisions will shape how your architecture evolves. You're always one decision away from degrading the level of evolution of your system. One decision away. Imagine a bird, for example, that decided to migrate it for a species, and they say, like, we're going to go south. How that change for that species, entire species? One decision away from shaping the evolution of your system, for better or for worse. Focus on the decision that matters. We have that framework, and I definitely recommend that book. Simplicity as a true north. Uncertainty is the complexity of best friends. Don't get in the trap of complexity. If you have something that is not certain, do an experimentation. Try to play with it. Make sure that it works and you have a better control of it, because that will give you predictability. And one thing that you will earn from that is the trust from your clients, the trust from your business, the trust from your executive. They will trust on you to make the following decisions and then the following decision. Don't break that trust. The moment that you break that trust, that's it. You jump into water falling, you jump into micromanagement. You don't want to be there. You always want to be in control of your system. Value of documentations and your decisions. We saw what happens in 1936. You don't want to be in that scenario where you lost completely the vision of your system, or even worse, you start drifting away from the original decision and you end up somewhere else where you didn't have to go. And make your decisions easy to reverse. Easy reversibility principle. I think I'm missing books here. Donella Meadows wrote a fantastic book, System Thinking, which is fascinating. I just remember that. But this, in software, fundamental software architecture, it now has the second part. It's called the hard part of fundamental software architecture, which is even more cool because it has use cases and things like that. It has been an absolutely pleasure for me to be here. Hopefully, we can stay connected and have conversations in the party. So thank you very much.